Hello everybody. This is the objective that we're going to talk about, basics of functions in their graphs. Now, first of all, let's figure it out. What is relation? Okay, let's figure out what is relation of the function. So the relation is any set of order pair. Relation is any set of order pairs. Ordered pairs. Okay, for example, I have 2 and 3. That's my relation. 3 and 0, that's a relation. 4 and 1, that's a relation. So these are called relation. The first number is always going to be domain, and this is another way to say x values. This is always y values, and we call it range. So these are just different vocabulary words that you need to know it. Okay, what is a function? What is function? Function means x never ever repeats, and every x has one y. Okay, exactly one y. So now if I give you an example right here, okay, not right here, it should be in order. For example, this is my example. I have the order pairs, like I have a set of order pair 1 and 2, then I have 3 and 4, and I have 6 and 5, and I have 8 and 5. Now, the question is asking, determine whether the relation is a function, and according to the definition, I said x never repeats. Do you see if x is repeating? 1, 3, 6, 8? No. Is every x has a 1y value? Yes. So yes, it is a function. Okay. So let's do something. Determine whether equation represent a function. So I'm going to give you another example. These are the order pairs when they ask you about the function. Now I'm going to give you an equation, like for example, x squared plus y squared equal 1. Is this a function? How would we know? You're going to change this to y equal mx plus b, like you make a y by itself. That's all I'm asking, okay? So it's going to be negative x squared and plus 1 because we subtract x squared both sides. So this is what I got. To get rid of the square, we're going to do square root, okay? So it's going to be y, let's do square root. There. So if I do square root, I'm going to get the square and square root cancel out, and I have 1 minus x squared. I just don't want this minus in the front. I just changed their positions. That's all I did. And since that's a square root, we have a positive and negative answer. So this positive and negative shows that for certain values of x, there are 2 values of y, which means this equation does not define y as a function of x. Like I have 2 y values for x. So it means no, this one is not a function. Okay? Because I have 2 answers, like I have 2 x values for y. Now, let's see. There would be a line test, like, okay, I'm talking about a relation in a function. Relation is just simple and order pair. Function, when x never repeats, every x has one y. Now, if you give you order pair, it's easy peasy. You just have to look at x never repeats, and every x has a 1y value. Y is repeating, that's okay. For the equation, this is an equation, you do the y by itself. If this was not positive and negative 2 answers, if it was just 1, then I would say, okay, it's a function because 1y has 1x, or 1x has exactly 1y. But in this case, I have 2 of these. So that's not a function. If you have a graph like this, it's called vertical line test you're going to use. Vertical line test. That's what you're going to use here, okay? Now, vertical line test means if you have a graph, you are going to draw a vertical line on the graph, anywhere on the graph. If it touches the graph twice, you see it touches here and it touches here. If it touches twice, then it's not a function. If it touches just once, it's a function. This is very simple. Okay, now let's figure it out. I'm gonna move them up there, so I don't want to waste space. The question is asking, find the domain and range of a function from the graph. Now, there is two different ways you write your domain or ranges. One way is called just interval notations. It's called interval notation. Interval notations. Interval notations are pretty easy, okay? If you they ask you write your answer as a set builder notation, then it's different, okay? And I'll show you set builder notation. This is something we do algebra 1, I think. Yeah. Okay, so let's see interval notation. First, let's talk about domain. What is domain? Domain is all x values. So I'm gonna pick up my pencil, and this is a domain. Do you see that? So, and domain goes left and right like a horizontal. This is the way you do it. Look at the strategy, watch the steps. This is a domain and you go left to right. So I picked it's a domain, it's a pink, so I'm going to use a pink color. So I'm starting, I stop. This is a graph. Where it starts? -2, okay? So I will write -2 here. And you know the -2 is a closed circle, like it's closed, it's a defined point. So it's like this. The closed circle are for every x, when it has a y value there, like -2, the y value is 0, then it means I have to make these brackets. Bracket means this is included. This -2 is included, which means it has a y value. Okay. Then I'm keep going, stop. Do you see? I stop, my graph stops right there, and it's 1. So, and 1 is also included because you have a closed circle. I'm just going to write here something. If you have included or included point or closed circle, or you can also use the word defined point, then it means you use these brackets. If it's not included, or it's going to be open circle, and it's not defined point, okay? So remember all of that. Now, this one, and by the way, this one is like, you can also say closed circle, or you can say less equal, greater equal. And this one is open circle, which means less than equal. Okay, these are all the things that you need to know. So domain, since it was closed circle, so I made a brackets. What is the range? So let's find the range, and I'm gonna write this in this color. Range means the y values. It's going bottom to up, down, up and down, up and down, up and down. So I'm gonna start with the bottom, because in the brackets, when you write, whether these brackets or these the parentheses or brackets, you have to write the smallest number first. Like the x value, it has to be first, not just x value. If these are both x's, but the first x value is supposed to be smallest. So that's why I'm starting from the bottom. That's why I started from the left. So I'm starting from the bottom. I go, stop. This is where my graph starts. Do you see what is that y value? 0. And it's not included. Is it included? I think it's included. Yeah, it's included because of the -2. It's a closed circle. So it's included. It's 0, comma. Then I start going, stop. This is a 3 and it's also included. Now let's find a set builder notations. How we do set builder notations. The set builder notation for the domain, you're going to do something, these lines, squiggly lines, and you're going to say the set of all x such that, now pay attention, this is -2 and that's closed. So I'm going to write 1x here. And do you see at -2 the graph goes greater than 2? Do you see? -2, I started, and the graph direction is in the right side, like it's greater, right side. So, and it's closed circle, so I'm going to go down. Greater equal to. Up here, that's 1, and do you know the graph is on the left side? The whole thing is on the left side of 1. So x less equal 1. And you close it. How do we do range? This is called set builder notation, okay? You're going to have a x, not x, sorry, y. This is going to be a y. The set of y values such that, and then go ahead and start, write y in the middle. If it's y, do you see, this is 0 for the y. And the graph is above the y. This 0, above 0, which means greater than 0. So it's going to be greater equal 0. Do you see? Okay, greater equal 0, because the smallest number always comes first. Okay. Now, this is what I got. Now, up here at 3, do you see the graph is below, which means that's less. Y is less or equal 3, and you close. This is set builder notations. Okay, let's do one of the question one more time. Okay, for this one, let's do this one. I'm gonna move this down right there. Okay, let's try this. Pink is going to be our domain. What is domain? My pink side, I'm starting with the left side, always left and bottom, okay? So I'm going, stop. This is where my graph starts. And you see it's open circle, and it's -2, so open circle, -2. Then I'm going, stop. This is 1, and it's closed circle. The x is 1, okay? And closed circle means it's this. Let's do the range. Range is going to be this color, actually. So I'm starting from the bottom. Go, stop. This is my graph where it starts, and it's -1. And it's included because it's a closed circle. Then I'm keep going, stop. This is where my graph stops. And that's a y value 2, but it's open circle. So it's 2 in open circle. So you know the parentheses are open circle and bracket is closed. How do you write this as a set builder notation? So domain for set builder notation, x, the set of all x such that, and you go ahead, write x in the middle. And if you see, my graph is on the right side of -2. Okay, I already know my axes are, my domain is -2 and 1. So since -2 is smaller, I'm going to write that -2 here, and I'm going to write this. It will make it easier, guys. Look. Then all I have to do is write down my inequality signs. So inequality signs, since -2 is open circle, so it's going to be these two signs, one of those. And my graph is on the right side of -2, right? Do you see that? That's -2 and the right side. Right side means it's greater. So x greater than -2. Greater, alligator mouth goes towards x. Now let's figure out 1. This is 1. And you see on the left side, we have a graph left of 1. Left means it's less. So what is less? And 1 is included. X less equal 1. And you're done. Let's do range for set builder notation. The set of all y such that, and you know I'm gonna write y here, and I have two y's. I already know this one is -2 and 1, so -1 is smaller, I'm gonna write there, and 2 is bigger, I'm gonna write there, and close. Now I have to set up my inequalities. This is range. You see, when I go to -1, the graph is above -1, it's not below -1, so above means it's greater. And it's a closed circle, so greater equal y greater equal -1. I read from the variable side, and you have to do that. Like when you decide it's greater or less, read from the variable side. Okay, and the alligator mouth is greater, so it's towards y, like y is greater equal. Then I'm going to go 2. You know, 2 is right there, the y value 2, but the graph is below 2, which means less. What is less? Y is less. Y less than 2, and I put this one because it's open circle. Okay, I hope you guys are understanding. If not, comment below and I will do more examples. Okay, identify x and y intercept of the graph. What is x-intercept? Okay, let's do red. Is this red or pink? That's pink. This is also pink. Change this to red. Okay, red. Since these dots are red, these are all x-intercepts. X-intercepts are equal. I have -3, 0. I have -1, 0. I have 2, 0. If you guys pay attention, I have 3 x-intercepts. X-intercept means when you crosses the x-axis, and your y has to be 0 for the x-intercept. Y has to be 0, otherwise this is not a y-intercept, x-intercept. Let's do in blue. What is blue? I think this is blue. I'm going to do, this is red, that's pink. What about that one? It's red. I'm going to change that to blue. Sky blue, light blue. What is that one? Light blue. So let's do that one. Okay. According to that, y-intercept. You see, y-intercept when it crosses the y-axis, and I have -6, 0, -6. Y-intercept means x always 0. So x is 0 and it's -6. So these are x-intercept and y-intercept. If you have any questions, guys, ask me in the comment. Any issues, problems, everything, talk to me, and also subscribe my channel, and have a good day. Bye.